It's news that really stops you in your tracks, doesn't it? Just a few weeks back, Air India flight AI-171, a Boeing 787 Dreamliner, crashed right after takeoff from Ahmedabad.
Yeah, truly shocking. And leaves so many questions.
Exactly. It's this kind of tragedy that, you just search for answers, try to make sense of something so huge. So today, in this deep dive, that's our mission. We want to try and cut through the noise, look at the evidence,
All the evidence.
all of it, and just deliver some clarity on what happened to AI-171, what it means for aviation safety overall, and how these incredibly complex investigations actually work. Okay, so to really get into this for you, we've gathered quite a bit. We've looked at official reports, expert analysis, even raw eyewitness accounts.
The discussions among aviation folks, too, right? People who really know their stuff.
Absolutely. The aim here is just to pull out the most important bits, the key insights, so you walk away feeling properly informed, not just headlines.
And what's, well, maybe fascinating isn't the right word given the context, but what's crucial here is how every single incident like this, horrific as it is, becomes a learning point.
A vital one.
Yeah, vital for global aviation, a really thorough, evidence-based investigation. It's not just about this one tragedy. It's absolutely key for improving safety, improving aircraft design, everything. Every little detail matters.
It could prevent the next one.
Exactly, that's the goal.
Okay, let's set the scene. So it was June 12th, 2025, Air India flight AI-171, a Boeing 7878 Dreamliner, scheduled flight, Ahmedabad to London. Takeoff seemed normal, initially at least, but then just moments after it left the runway, tragedy. Very, very swift.
Yeah.
The aircraft just plunged. The loss of life was immense, 241 people on board, and another 9 individuals on the ground as well.
Terrible. And amidst all that, somehow one survived.
One survivor, Vishwas Kumar Ramesh, a British citizen. An absolutely harrowing story there.
Incredible that anyone survived.
Truly. And here's something that really speaks volumes, I think, about the crew's professionalism right up to the very end. Captain Sumit Saparwal.
Very experienced pilot.
Hugely experienced.
Yeah.
Over 8,200 flying hours. In those final terrifying seconds, he managed to get a Mayday call out to air traffic control.
Yeah, I read about that. What did he say exactly?
His message was chillingly clear. Thrust not achieved. Falling.
Wow.
And this was all within about, 25 seconds that the plane was even airborne. Something like 11 seconds to get to 600 feet, then maybe 15 seconds coming down.
So almost no time at all.
Barely any time. But he still tried to control it, still tried to communicate. Just shows that instinct, that training.
Absolutely. And, Captain Minu Ruchivadia, another experienced pilot, she pointed out that the initial visuals, they suggested a normal takeoff run.
Right.
Which kind of immediately threw cold water on those very early ideas about it being too heavy or not having enough power initially. Yeah. She explained, if a pilot feels they don't have enough speed for lift, the standard procedure, the immediate reaction, is undercarriage up, nose down slightly to gain speed. It's basic training.
Something they drill constantly.
Constantly. And Air Commodore B.S. Siv also highlighted the pilot's calm. I mean, incredible calm, considering they obviously knew they'd lost thrust, lost lift, but still trying to fly the plane, still making that call.
Just remarkable composure.
It really is, under impossible circumstances.
So that's a powerful point about the pilot's actions. But it does bring up that question people were asking early on, right? So what about the plane being too heavy or using a really long runway? Any truth to that speculation?
Yeah, it's worth addressing. The thing is, the Boeing 787, it's designed to handle weights much higher than the typical specified loads. It has margins.
Okay.
And pilots, they don't guess. They use sophisticated flight management systems, the FMS, to calculate exactly the power needed, the flap settings, for every single takeoff, considering all the conditions.
Even the heat in Ahmedabad. It was hot that day.
Extremely hot, over 40 Celsius. And that does affect things. It creates what we call density altitude. Basically, hot air is thinner, so the plane performs as if it's at a higher altitude.
So it needs more runway.
It does need more runway, yes. In Ahmedabad's case, even though the airport's only about 200 feet above sea level, the density altitude was probably closer to 3,000 feet that day. But, and this is the key point, that's well within the operational limits for the aircraft and the crew. Experienced pilots, modern jets, they account for this routinely.
Right. It's calculated. It's not a surprise factor.
Exactly. It's part of the standard calculation.
Okay. So as the investigators start digging deeper, some really critical visual clues emerged. They painted a pretty stark picture of those last moments. There was this video, wasn't there?
Yes, from a young eyewitness.
A 17-year-old Aryan filming from his rooftop. That video plus airport CCTV, they showed something really perplexing.
What was that?
Well, two things. First, the plane's landing gear. Still down, extended,
After takeoff. That's unusual.
very unusual. And second, perhaps even more critical, the wing flaps. They looked like they were retracted.
Retracted during takeoff.
Yes.
Okay, that's significant. Aeronautically speaking, that's the opposite of what you want. You retract the gear after takeoff to reduce drag,
Right.
and you deploy the flaps for takeoff to generate lift. Retracted flaps mean drastically less lift. That's wow.
But here's the counterpoint. A senior pilot from Air India's 787 fleet said pilot error on the flaps was highly unlikely.
Why is that?
Because the Dreamliner apparently has tons of warning systems. Alarms, lights, you name it, if the flaps aren't set right for takeoff. And the crew, as we said, highly experienced.
Okay, so warnings should have gone off.
That's the thinking.
Mhm.
And Captain Sohail Honda added another point. He said even if, somehow, a Dreamliner got to 600 feet without flaps, usually one engine would be enough to keep it flying.
Implying something more catastrophic was happening than just a flap issue.
Exactly. Suggests a deeper problem. So if it wasn't likely pilot error on the flaps, what else? This brings us to what some experts are calling, like, the potential smoking gun. Also visible in Arian's video.
Which is?
A small object sticking out from underneath the plane, identified as a ram air turbine.
Your RS.
Ah, the RET. Okay, that is very significant.
Explain that. Why is the RET so critical here?
Well, the R8, it's an absolute emergency device, a tiny turbine driven by the airflow. It only deploys automatically in really severe situations.
Like what?
Think total electrical failure or total hydraulic failure, or both engines failing. It pops out to generate just a tiny bit of power for the absolute essential flight controls and instruments. It's the last resort.
Wow. Okay.
And this connects directly, potentially, to what the sole survivor reported, right?
Yeah.
A loud bang and the lights flickering just before the crash.
Ah, I see.
Experts think that bang could have been the sound of the RET deploying and the flickering lights. That could be the sudden draw on the plane's very limited backup electrical power when the R8 kicks in.
Okay, that makes sense. Plus, there's apparently a sound in Arian's video, a sort of propeller-like noise, different from the normal jet engine sound of a 787. That strongly suggests the RAT was spinning, it was deployed.
So its presence is almost confirmation of a massive failure.
Pretty much. Its deployment tells you instantly the aircraft was in deep, deep trouble, likely a major power system failure.
So it's not just one thing, then. It's how these pieces fit together, isn't it? The pilot's words, thrust not achieved, the RET deploying, the landing gear still down.
Exactly. It paints a compelling picture.
It's like all the evidence screams one thing, a total loss of power, or at least control over the thrust.
Precisely. That combination, the RAT, the pilot's call, the gear, it points very strongly towards a catastrophic loss of power or thrust. That becomes the main focus.
Okay. So if a total power loss seems like the most likely immediate cause, the big question for investigators becomes why? What caused that failure? Pilot error seems largely off the table based on what experts are saying, so they're digging into technical, operational theories. The first big one seems to be fuel contamination.
Yes, that's a prominent theory. S.J. Muralidhar, who used to be with the National Aerospace Labs, and Neil Hansford from Strategic Aviation Solutions, they both raise this.
What kind of contamination are we talking about?
Could be several things. Water in the fuel is a classic one, or debris, microbial growth, even potentially contamination from other fluid like diesel exhaust fluid getting mixed in somehow.
And that would cause
Blockages, it could clog fuel lines, filters, injectors, leading to the engines not getting enough fuel, losing thrust, or potentially flaming out altogether.
Has this happened before? With Dreamliners specifically?
There was an incident, yeah. March 2019, a 787 in Japan. It had a dual-engine issue traced back to fuel contamination. Thankfully, that one landed safely.
Okay, so there's a precedent.
There is. And if this turns out to be the cause for AI-171, then the investigation obviously zooms in on the fuel supply chain at Ahmedabad Airport.
The suppliers, Indian Oil, Bharat Petroleum, Reliance.
Exactly. And their testing procedures. How rigorously was the fuel checked before it went into that aircraft?
Right. So fuel contamination is one major avenue. What else? Especially for a total power loss. That brings us to electrical failure, right?
Yes, that's another significant possibility. A senior pilot suggested a failure of the aircraft's variable frequency starter generators, VFSGs.
Okay, what do those do? in simple terms?
Think of them as like the main electrical power source and the starters for the engines. Crucially, they also power the electronic engine controls the FADE systems, the engine's brain.
So if the VFSGs fail,
If they fail, the electronic controls might lose power. Even if the engines are mechanically okay, the pilot can't command them. They lose control of the thrust.
but aren't there backups? APUs?
There are auxiliary power units, yes, but they take time to start up, maybe up to 90 seconds.
And AI-171 had maybe 25 seconds in the air total.
Exactly. No time. So if the main generators go offline and the APU can't kick in fast enough, or if there's a disconnect in the power distribution, you could lose the ability to manage thrust completely.
And we have seen issues with 787 electrical systems before, haven't we? The battery problems back in 2013.
We have. That led to the worldwide grounding, remember. Lithium-ion battery issues causing smoke, fires, melted components on a couple of Japanese flights.
Right.
It highlights just how complex these electrical systems are and potentially how vulnerable they can be. A small component failure can have massive knock-on effects.
Makes you think. Now, shifting gears slightly, but still on the technical side, we have to talk about the aircraft itself. The 787 Dreamliner overall has a great safety record.
Excellent record, yes.
But this crash, it's the first hull loss for the type, isn't it? The first one completely destroyed in a crash.
That's correct. After millions of flights, hundreds of thousands of flight hours, it's significant.
And it comes against a backdrop of some really troubling allegations about Boeing's manufacturing, specifically for the 787.
Yes. There have been quite a few reports and whistleblower accounts over the years, particularly concerning the Charleston factory in South Carolina.
Like what specifically?
Well, you had Norwegian Airlines back in 2020 complaining about recurring engine problems on their Dreamliners. Issues serious enough they had to scrap a relatively young plane.
Okay.
Then you had investigations, Al Jazeera, New York Times, claims from current and former Boeing employees about negligence. Things like parts not fitting together properly because they were made in different places.
The Sam Salapur allegations.
Exactly. Engineer Sam Salapur filed an FAA complaint just this April, claiming 787 fuselage sections were improperly joined, creating a risk they could break apart mid-flight. He said management ignored his concerns.
That's alarming.
Very. And others claimed faulty parts were used, metal shavings left inside planes, pressure to cut corners and hide violations. One technician apparently told his wife never to fly in a Dreamliner built there.
Wow. And then there was John Barnett.
Yes, John Barnett, the former quality manager, he was very outspoken. He basically said no 787 from Charleston was safe. And he made a chilling point. He reckoned manufacturing defects might take 10 or 12 years to show up as a major failure, like a crash.
And the crashed Air India plane, AI-171, how old was it?
It was delivered 11 years earlier, January 34, 2014. Right in that time frame Barnett mentioned.
And there was another specific claim, wasn't there, from Cynthia Kitchens?
Right. Cynthia Kitchens, another former quality manager from Charleston. She flagged 11 specific Dreamliners delivered around 2012, 2013 as having problems. 6 of those went to Air India.
6.
And she recounted a manager telling her something like, don't worry, none of those planes are staying in America. They're all going overseas, implying perhaps a different standard for international customers.
And AI-171 was delivered during that period.
It was. Falls right into that time frame she was concerned about.
So, okay, if it turns out to be a manufacturing defect, the blame points pretty squarely at Boeing, right?
You would assume so, yes. That would be a huge issue for Boeing, given these prior warnings and allegations.
But what if it's not manufacturing? What if it's maintenance?
Then the focus shifts. Air India Engineering Services Limited, AIESL, handles most of the maintenance for Air India's 787s. They're government-owned.
How recent was the maintenance on this specific plane?
Its last big check, a C check, was about 2 years ago, June 2023. More recently, the right engine had some repairs done in March 2025, and the left engine was inspected in April 2025. So there was recent work.
Sure.
But beyond the plane itself, we also have to consider Air India's own operational context. There have been issues reported there, too.
Like what?
Reports of pilot fatigue being a problem. Remember that mass sick leave back in May 2024?
Yes.
And a DGCA audit in July 2023 apparently found some issues, like fake safety reports, protocols not being audited properly.
Not ideal.
Not ideal. And even the day before this crash, there was another incident on an Air India flight. Multiple passengers and crew getting sick, possibly food poisoning. It points to potential wider systemic issues that need scrutiny.
Right. So lots of potential factors swirling around. Which brings us to the investigation itself. Who's leading that?
India's Aircraft Accident Investigation Bureau, the AIB, they're in charge. The Director General is GVG Ugandar. They've put together a big team.
And they're getting international help.
Yes. Crucially, experts from the U.S. National Transportation Safety Board, the NTSB, are involved. That's standard practice when a U.S.-manufactured plane crashes overseas. They represent the state of manufacture.
Okay. And this investigation, it seems to be taken extremely seriously at the highest levels. Security measures.
Absolutely. The head of the AAB, Mr. Ugandar, was given X-category security. That's based on an Intelligence Bureau threat assessment. And the black boxes.
The flight recorders.
Yeah, the cockpit voice recorder and the flight data recorder. They were kept under 247 police guard and CCTV surveillance after recovery.
That signals how sensitive this is.
Extremely sensitive.
Right.
And the Minister of State for Civil Aviation, Muralidhar Mohol, he explicitly confirmed that sabotage is one angle they are actively looking into. They're reviewing 30 days' worth of airport CCTV footage.
Wow. Sabotage. That adds another layer entirely.
It does, though it might just be procedural, covering all bases.
And the black boxes themselves, there are rumors they might be sent overseas for analysis.
Minister Mohol clarified that. No, they were analyzed in India. The data from both the CVR and FDR was successfully downloaded in Delhi by June 25th.
So they have that crucial data now.
They do, which is vital. And, this specific investigation, it doesn't happen in a vacuum. It feeds into India's wider approach to aviation safety.
How so?
India's aviation authority, the DGCA, has a strategic plan, the National Aviation Safety Plan, or NASP, for 2024-2028.
Okay.
It lines up with the global plan from ICAO, the International Civil Aviation Organization. And its headline goal is incredibly ambitious. No fatal accidents in commercial aircraft operation.
0 fatal accidents. That's a huge aim.
It is. And it stresses building resilience throughout the whole Indian aviation system.
What are the main pillars of that plan? How do they aim to achieve that?
Well, there are 3 core goals. Goal 1 is about continuously reducing risks. They've identified 8 high-risk areas for India, things like loss of control in flight, runway safety, and importantly here, deficient maintenance.
Okay, makes sense.
Goal 2 is about strengthening the DGCA's own oversight capabilities, using more proactive methods, looking for risks before they cause accidents.
And goal 3?
Goal 3 is about implementing an effective state safety program. A big part of that is fostering what they call a positive safety culture. That means getting everyone involved, airlines, airports, maintenance crews, pilot, controllers, to prioritize safety proactively.
Culture is key, isn't it?
Absolutely fundamental.
So we have this big investigation feeding into a broader safety plan. When can we expect to hear some initial findings from the AI-171 investigation?
The expectation, based on international guidelines, is for a preliminary report around July 12th, 2025. So quite soon, actually.
Yeah, we'll definitely be watching for that. Okay, so let's try and pull this all together. What does it all mean when you synthesize this, well, incredibly complex picture?
Yeah, it's a lot to take in.
It really drives home that idea of the Swiss cheese model in accident causation, doesn't it?
Absolutely. It's rarely, almost never, just one single thing.
Right. It's like you have these layers of defense design, manufacturing, maintenance, operations, training. Each layer might have small holes, imperfections. A catastrophe happens when, just by chance, all those holes line up.
The hazard slips through all the layers.
Exactly. And here we're seeing potential holes aligning, possibly, in manufacturing, maybe maintenance, maybe operational factors, maybe a technical system failure, all potentially contributing.
It's a stark reminder. And while this crash is, of course, a terrible tragedy, the investigation itself is so critical.
The learning process.
Yes. Bolstered by frameworks like India's NASP and international cooperation, every single piece of evidence they uncover, whether it's from the black boxes, the wreckage analysis, that pilot's final call, even tiny component failures, it all provides invaluable data.
Data to hopefully prevent it happening again.
That's the entire purpose. It's how aviation has become progressively safer over the decades, by learning painstakingly from every single incident.
So here's maybe a final thought, something for you, the listener, to ponder. It really makes you reflect on how deeply interconnected this whole aviation world is, doesn't it?
Really?
Think about everyone involved, the engineers designing these incredibly complex machines, the workers assembling them on the factory floor, the maintenance crews keeping them airworthy day in, day out.
The pilots and cabin crew, the air traffic controller.
The regulators setting the standards, the fuel suppliers.
Yeah.
It's a massive ecosystem, and it highlights that constant delicate balance, perhaps. The balance between the push for efficiency, for profit, and the absolute paramount need for safety.
It's a tension that's always there.
It is. And how the lessons learned, painfully learned from AI 171 will inevitably filter through that entire system and hopefully make air travel safer for all of us in the future.
That has to be the outcome.